Hi guys, good day. This is Engineer Regan. Once again, please join me as I will try to discuss factoring. And this time, we will specifically talk about the difference of two squares. Okay, so when you talk about the difference of two squares, you only have to remember two things. The first thing you need to remember is each of the term of the binomial has to be expressed in terms of a square, meaning it has to be something that is raised to the power of 2. So each term has to be expressed into this one. Okay, that's the difference of two squares. Each of the term has to be expressed to the power of 2. Okay, and then the sign between them, the operation should be minus. That's why it's called the difference of two squares. So when you factor this, a squared minus b squared, the factored form of that is actually just the base. Okay, the base of a squared is a, the base for b squared is b. So actually, you just have to copy those bases, and then the operations between the two is plus and minus. Easy as that. Okay, so let us have a example. So in this example, you have y to the power of 4 minus 4. Okay, to make it easier, express first each term into a square. So y to the power of 4 can be expressed into y squared to the power of 2 minus 4 can be expressed into 2 to the power of 2. Okay? Now, since we have already expressed each term into the power of 2 or expressed into square, all I have to do now is factor them out. So the factor for that should be just copy the bases. That's y squared minus 2 and then y squared plus 2. Okay? Let's have another example. How about this? 9x squared minus 16b squared. Again, express each term with into a square. So 9x squared can be expressed into 3x to the power of 2, right? Okay, check it out. 3 squared, that's 9, see? X to the power of 2, that's x squared. Minus, okay, how about 4b squared? That is, but actually you just have to get the square root of the coefficient. So square root of 16, that's 4. That's 4. How about b? Okay, 10 to the power of 2. See? So again, we now have expressed our binomial into its squares. So the next time, again, is to express it into its factored form. The factored form actually is just what? You just copy the bases once again. So that says 3x and 4b, 3x and 4b. And then just vary the operation, plus and minus or minus and plus, either way. Okay? You have to remember this. The operation varies, okay? If you place plus here, then the second factor becomes minus. Or if this is minus, the second factor is plus. You can't have it both plus or both negative. You can't have it both plus and both minus, okay? It has to be plus and minus. Okay, lastly, let's have the last example. Okay, that we have here y minus 5x squared minus 64. Okay, don't be confused. This example might look a little confusing because the first term is already a binomial, but don't worry, because as long as the first term is expressed into a square, doesn't really matter actually. So in this case, you have y minus 5 squared. This is already expressed in squared, so you don't have to do anything about that. But on the second term, you will have to express it into a square, which is what? The square of 64 is 8 squared, right? Because 8 times 8 is 64. And again, This time, get the factored form. The factored form for that is y minus 5 minus 8 and y minus 5 plus 8. And then further simplify that. That becomes y minus 5 minus 8, right? And y minus 5 plus 8. So ultimately, you will have negative 5 minus 8, you have 13. Y minus 13 and negative 5 plus 8, you get 3. So y plus 3. That's your final answer. So the factored form for this binomial is this. Okay? Easy, right? So I hope, there you go again. I hope you were able to understand now how to factor difference of the squares. Bye.